Hello everyone and welcome back to Power Playground. This is your host Michael, and today we are continuing our video series on creating a circuit board for my 3D printer design here. Now, to recap what happened in the last episode is we created a schematic as well as a board profile in Fusion 360, which looks a lot like this. So we have our interface board design here, and we're ready to go ahead and start making our circuit board in Eagle. So let's go ahead and pop on over to Eagle, and not schematic design, we're going to go into the board design. So when we're going to, in our project, we want to right click, new, and then go to board. We already have our schematic created, so we want to create our board. Now I already have mine created, and it's not the exact shape, so we need to sync it with Fusion 360. As you can see on the right hand side of our board design interface, we have the Fusion 360 button. We want to go ahead and click that, and it'll bring us to a little wizard. Now we have a couple options. We can create a new Fusion 360 design and then link to an existing Fusion 360 design. So I want to do that, hit next, and then we'll want to go ahead and click on our profile. We'll want to go to the printer, and this is going to be under the hot in assembly. Now there's a couple of PCBs. I think it's going to be PCB 2 just because that's the one, that's the newest one I have here. As you can see, pull from Fusion is out of sync, so we'll want to go ahead and hit pull from Fusion, hit pull. As you can see, the default profile for our board has changed from the square to our design we made in Fusion 360. Right off the bat, as you can see, we have our 5 components from our schematic. So we have our fan headers, the main header, as well as the thermistor header and the in-stop header. So what we'll want to do is we want to place these on the board and lay them out. First off, I'm going to go ahead and go up to the move tool. And like I said, you have to pay attention to see which crosshair on each individual part you need to click on. So in the board view, it is our yellow crosshair. So we want to click on that. We're going to start with our main, click on that. And then we'll want to move it in, and I'm gonna go ahead and rotate it properly. So that's where I want it to be. And as you notice, as I'm moving this, these yellow lines, these tethers between each contact seem to change spaces real quick. Now what I want to do is I want to go ahead and flip this around. Okay. Let's make sure, see what we got here. All right. One issue I do see here is that everything is flipped around, so I'm gonna have to do a quick little, hey, there we go, okay. Oh, let's move you around. So that's pretty much right. Okay, I think we got it. Yeah, there we go, fixed it. Cool. So we just want to move everything into the space just for now, and we'll figure out the rest of the logistics here later. I'm just going to get these guys flipped around. And yeah, right clicking when you're in the move rotates it as well as using the rotate tool. So that's just another little tip. So click this guy. I'm going to rotate it sideways like this. And then I just want it to make it so it's directly hooked up. And this guy I want to move up here as high as possible next to our group here. Trying to make these pin connections as straight as possible to this in stop. Just want to feng shui everything around, and these guys I want them to be a little bit tucked in, so right about here should be perfect. I don't want them poking out too much past this edge because I don't want these contacts to be sticking out past the fan. There we go, that'll be fine. It's maybe a little bit different from what I had to design initially. So I'm just moving the text around, getting it nice and organized. Now, as you can notice, the actual movements, they're a little too restrictive. So if we go up here to grid, click on that, we can change our grid constraints. So right now it's 50 mil. I'm going to go ahead and set that to 10 mil. That'll be fine. Now these mils are essentially thousands of inches. Okay, so we have our contact names. Let's try to keep these, there we go. I just like to keep everything nice and well taken care of. Now, say if you want to remove a label like this, I don't need this, that's useless to me. I'm going to go ahead and trash that, which there should be, yep, there's our delete icon, or delete thing, so I'm going to delete those two. They are useless to me. Now, another thing I want to do is I want to flip just this text, keep it on this side. So there we go. And then I want to move this guy back just a little bit here. Maybe tuck it in a bit. There we go. Neat. Then move the thermistor labeling. I'm just going to put you right here. End stop. I'm going to put you right here. There we go. Keep in mind, this is the bottom of our layout, and this is the top of the actual board. So it just flipped around a little bit. Don't know how to get it flipped around. I'm sure there's a way to do it, but I'm not too worried about it right now. So we have everything lined up where we want it here, and the basic labeling scheme. Now I can also go into the text tool. For instance, if I want some positive signs to notate which is which, I can go ahead and do that. Ooh. Oh, I'm on the wrong layer. Okay, that's why. Now, as you can see, right now it's in red. That we don't want that because that's going to be the actual ground plane layer or the actual circuit layer. So the top and bottom layers, those are going to be where your circuit traces are for the board, and then the dimension. That I can't remember exactly. Oh, I guess that's just the actual outside of the board itself, where it gets CNC'd out. Now we want the names to be on T names, B names, or T place or B place. Those are, or T values and B values. Either of those 6 layers will work. You can do T names to be fancy or proper. So I'm gonna go ahead and do that. I'm gonna add in, I need at least, so I need 1 for the cool up here, and then I need 1 for the end stop, or 2 for the end stop technically, and then another 1 for the extruder. And then I'm going to go ahead and add in a few minuses. So I'm going to need about an equal amount of minuses here. And then I'm going to need a S for signal. So those are a little bigger than our pluses. So what I want to do is right click on that, go to properties, and then we'll change our size, which is essentially just a font size. I believe 50. Yeah, that'll work. So I'll change both to 50. So right click properties, size, 50. Okay. So now we have all of our little notators here. I might bump the size up on these just a little bit to get them even. 80. Yeah, there we go. Or I guess 86 will do. Sure. Now do keep in mind, depending on what board board shop you use, they may not be able to properly support what you need in terms of sizes of text. So if you get really small, you may run into issues. So keep that in mind. So I just have a couple little polarity marking, or a few polarity markings for each individual thing. That'll be our positive on that side. And these little crosshairs do make lining up these things pretty dang easy. For our end stop, have our negative. I want to go ahead and flip that to its side. And we'll go ahead and, I'm just going to say signal is going to be the middle one. You always properly label everything on your board. You never really think about it. You don't really want to go ahead and just have it to where it's like, oh, hey, I don't have a proper way for everything to be labeled, so I don't know what the heck it is. So may want to move these two, flip them around. That may make life a little easier for us. So I'm going to go ahead and do that real quick. All right, cool. We've got everything lined up pretty decently. Another thing I'm going to do is I'm going to move this guy down a bit. You're going to see why here in a moment. I'm going to do some extra labeling. Move these down a tidge. Perfect. Okay. ENDSTP. Insert that. I'll size it up next, and then we'll do another one. Cool. Okay. Cool. So we got these. I'm definitely want to size them down a bit. Way too big right now. Let's see. 50, is that going to do it? Oh no, I want it smaller. Okay. So 32 maybe? A little too small. I'm going to do 40. Ah, perfect. So essentially I'm just matching up to these pins here. Change that to 40 point as well, just to keep things consistent. Or actually, I don't need this. I'm gonna delete it. Okay. Oh yeah, I'll do another therm as well. That's what I want to label. Because you may not be able to see the traces because they're so small. I just want to make sure I have a label. Probably want to do like a little revision tag as well. Revision 1.0. And then I don't really have enough room for like whole design by. There we go. Just tag it so everyone knows we're here. Make that just a pinch smaller. I don't need a full set of recognition here. There we go. That's perfect. Right there. Boom. And also another note, there are different fonts as well, so you can do proportional, vector, or fixed. I personally like proportional just for a good clean look. Very simplistic. It doesn't have like the old school like arcade font look. Now what I want to go ahead and do is I want to start laying out traces. I want to go ahead and click the route button on the left hand side, and I want to make sure that I'm not losing any resistance, especially in something like the thermistor. And I really don't have to worry about like too many wires in one place just because this is a really simple design. I'm going to go ahead and do a width of, I think, about 16. That should be more than enough. So essentially, if you zoom in a bit here, you can see our circuit design. So I could do this. You can kind of like snake it around, and you can also click in certain places if you wanted to look. I think this is going to be the tidiest way to do these guys. And I like to make them look as neat as possible to where they're spaced out evenly. So if I wanted to do this number here, just make it so they're evenly spaced out by both sides, and they just look super duper clean. Especially it'll look really neat when the board is actually manufactured and made. So we're just clicking from point to point. Try not to like click within like areas like this so you don't create little nubs unnecessarily. So we have our ground. Actually, we don't need that ground because we're going to make a ground plane, which I'm going to show you in a little bit here. So now we have these guys. These are actually flipped around, and if I wanted to, I could. I'm going to go ahead and do this real quick. There we go. Just move you around. There. Okay, so now that's nice and neatly routed here. I think that should be right. We'll figure out here in a moment. No, that should be fine. Okay, so now we'll route this guy here. And yeah, for some weird reason, it just loves binging and making a bunch of noise. So kind of, there we go. So as you can see, as I'm drawing out these lines, we are removing these yellow lines here, replacing the red lines. Now you can also go switch to the bottom layer. There's, in the free version of Eagle, you have up to 2 layers. I think in the paid versions, you can go all the way up to 16 layers, which for our design, there's no need for the bottom layer or the, so we're just going to use the top layer because that'll be the visible layer. And it's kind of cool to see the traces. I personally like showing them off at least. So now what we want to do is we want to create our ground plane, which is our next step thing here. Now, the way to do that is we want to go into the polygon tool. You could also use the rectangle tool, but since this is a non-standard shape, we'll want to use the polygon tool. Now make sure we're on the correct layer, which I'm probably going to do this on both layers and have it stitched through, because making a large ground plane like this will act as more or less like a heat sink. We're going to go ahead and click on the polygon tool, start with one of our edges here. Actually, one thing I want to recommend doing is setting this all the way down to 6. Now, another thing is you will want to check with the actual board manufacturer you use. A lot of them are, the minimums are set to 6mm for this width here for the actual traces. and you'll want to definitely abide by that if you don't want your board to look like crap or come out with a bunch of errors. So we'll just want to click and follow this contour as smoothly as possible. Am I on the right? I think I am. Let's try this. Make sure we're on polygon. Okay. I'll have to check the settings between this and my laptop because this is definitely different. It's acting in trace mode for some weird reason. Last time I did it, it acted a lot different from this. But it's fine. The reason I'm doing this is just to make this a little cleaner. I try to want to keep it as close to the yellow line as possible, just to and not go within the black area we have here, and try not to go out too far, because I don't think it'll create a huge issue, but just in case if it does. So ideally, I want this solder mask to conform to the shape of the actual board itself, not go anywhere outside of out of bounds. And then it'll ask you for a signal name for this polygon. We're gonna go ahead and do GND for ground. And then, as you can see, there's like a little dotted line on that we drew here. So what we'll want to do to create this ground plane is click on the rat's nest. And as you can see, we have ourselves a full-on ground plane that extends out through the entire length of the board. Now, if you notice, these contacts labeled ground that we had the little dead end, or that little end on the schematic. Let's go back to our schematic view. So since we added this ground, it recognizes these three contacts as the ground plane. As you notice, there are little lines going on each side, both top, bottom, left, and right, on each of these ground contacts that splices them into this general ground plane. So just makes routing a little bit easier. So for instance, it can just go all around the board, makes a nice clean contact. You don't have to worry about drop off or anything like that. Plus it makes it look really cool when you have the solder mask on, because this will all be copper underneath. It's usually a good idea to have this underneath the solder mask, which is just the mask that protects most of this red area. Of course, on the green area, that's where it's exposed for the contacts. So it just looks really cool to have this whole ground plane here. Now I want to go ahead and create one on the other side. So we'll go ahead and go to bottom. We'll hit our polygon tool again and do the same exact thing. I'm going to fast forward real quick while we do this. All right. So I'll do the same thing, GND for this signal name, and then I want to click on rat's nest again. As you can see, if we switch between the bottom and the top layer, we have that same ground plane. Now, as you can see on both sides, all these grounds are connected. Now, another good practice for these is we'll want to make some vias. Now these are basically contacts that go between both sides of the boards. You can use them to connect contacts that may be kind of in like a dead end area on one side but may be freed up on the other. For instance, if you have like a big old like integrated circuit or something like that, like an Arduino or like a Atmel style chip with like all four sides have contacts, and you might have to like go in the middle of the chip just to where the contacts are, just to make some things connect to each other. So I want to go ahead and litter these all over the place. All right, so I can't remember exactly how I manage these or turn these guys into non-ground, so I'm just gonna go ahead and wing it. Just create quite a few of these. So these are just going to connect both ground planes together. I know there's a quicker way to do this because I've done this before. Should be a way to select multiple, but for now I'm completely at a loss of trying to figure that out. But yeah, we just want to connect these bad boys all to ground. Just gonna fast forward this real quick. Okay, wasn't too bad. All right, so here's the next thing I want to do is I want to make sure. Okay, cool. That is exactly what I want to happen here. As you can see, tplace has all of our text. So I want to make sure everything's on the right layer. Now these guys are on the bottom. I wanted that. I didn't want these guys at the top just because they'll kind of interfere with some of this other functionality here. So T-place, this is what the diagram is going to look like. These guys are going to be cut off more than likely. They're just going to show on the other side, I guess, for kind of like an installation instruction. So they'll be flipped on the other end there. And then these guys are fine because we'll want to keep them on this edge. Now we have our board ready to rock. So we're going to go ahead and do electrical rule check. So that's going to check our schematic real quick. Now we just have some no value stuff, so we can clear that. We don't need to worry about that. Go back to our board view. We're going to do a design rule check. Now, typically you can leave these by default. I don't edit any of this stuff. If your board manufacturer has any specific tolerances, or say if you're like doing this stuff DIY, you may want to ramp up these values, but 6 mil is typically a standard minimum throughout most of the actual companies I've used, at least. And these guys here, I'd still keep those about the same. That's perfectly fine. Keep in mind the mils are thousandths of an inch, and obviously you have millimeters as well. So in case of like, say maybe your board shop has like a different size minimum drill bit, you may want to account for that. And maybe if you're doing like a more intricate design, you might have smaller tolerances to work with, which cool. But for our design, we can just keep everything as default. So always check with all of these things. And like I said, I'm going to link Jeremy Blum's video in the description, like I said in the first video, because his videos go a lot more in depth than the particulars. But this is just a quick and dirty design, nothing too complicated here. So I'm going to go ahead and do a quick check on this, and then this will return. At the bottom it says no errors. Left click, obviously we can change names or whatever we want to do. But yep, looks like we are ready to go. So we're going to save this here. Now what I want to do is I want to test the fitment in Fusion 360. So I'm going to click on the Fusion 360 tab one more time. And if we see push to Fusion, that is out of sync right now. So we're going to go ahead and push to Fusion so we can get everything taken care of. We're going to get some errors with the packages for the JST style connectors because those don't have a 3D view, unfortunately. I just gotta wait. Oh, there we go. We're good to go. So let's go ahead and switch back into Fusion. Now, one thing you'll have to do is we'll have to go ahead and close out of our file. Make sure there's no saving or no things you want to save over to overwrite it, or also we'll have to sync again. And there we go. We have our board now. All right. Now this, oh yeah, that's our old design. Okay, cool. So this is our design. It has all of our little pieces and whatnot in here. Now, another common practice to do for the board design is we could put in like some fiducial markings, which is another library I can import, but I don't really think it's necessary for this design because all of this stuff will be hand soldered on. It's not going to be machine soldered or anything like that. So I'm not going to worry about any sort of extra markings for a machine to identify. That's just nothing I have to really worry right now. I think I put in the other board that I did, the previous design, but this one worked just fine. So there we go. Everything's nice and tightly tucked. These guys look great. There's no conflict issues here. This little thing that's sticking up for the actual filament, that shouldn't really conflict with these guys because they're so high up on the board. And then, of course, they're not going to stick out too far, just a little bit past this wheel here. And that shouldn't really have any sort of conflict issues with that. So there we go. The board is good to go. So once we verified our board design's good to go, works out, Copa setup with Fusion 360, we'll want to go ahead and go to CAM design and then go save our file, obviously, or CAM processor, sorry. So as you can see, we have our various different, so this is like our copper. It shows all of the profiles. So this is going to generate all the files to tell the actual shop what it needs. So for instance, I could delete this. Like if I don't really need this layer, so I could delete it, or I could just delete it from the zip itself. I might just go ahead and generate it just to be on the safe side. So what I'm going to go ahead and do is, if everything looks correct, for instance, all these profiles look correct with the ground planes and what have you. And then there's, of course, the drillings as well, which you can't really see, unfortunately. It may show it on your file, or when you go to actually order up the board there, the company may show you like a little preview just to check everything out. Now that everything looks good to go, we got all our labels and all that stuff's pretty decent looking. Let's zoom in here, make sure that looks fine. It may look a little rough in this preview here. I don't know why it looks so rough, but I've had boards printed out in the past, and they don't look nearly as rough as they do in this preview, especially all the text and what have you. So I'm going to go ahead and hit process job. We're going to save this. Yeah, we'll just select that. Okay. Let's open the folder. So now we have this here as our CAM outputs. That's going to be all of our files. This is going to be our Gerber files. So we'll want to put this on a zip. Now, usually they'll also want the drill files as well. So I'm going to go ahead and copy that, paste it in this folder. And then I'm going to go ahead and add these all to a zip file. So I'm just going to show you a couple services that I use. One is JLC PCB. They are out of China. So obviously it's going to take a little longer for them to get your order out, but they are a great and really cheap solution here. So what I can do is I can have them do like a prototype. So say if they're really good for like large orders. I think I ordered 100 pieces and it was like $80 for the whole job, and they DHL shipped it too. So if you get big orders through them, they may use like a faster shipping method like DHL, which takes like 3 days to ship once they're done manufacturing, compared to like an e-packet type deal where it may take a couple weeks. I think it's about 50 by 50, or let's see, 55 by 55. That'll give us a more accurate quote here. Layers and thickness, like I said, 1.6 is the average here, so we can go to our quote. And then we're going to look for our Gerber file. One thing I would recommend is saving your projects into some sort of like cloud-based thing or some sort of backed up directory, because by default, I think it'll just save your Gerber or all of your Eagle files and projects to the documents folder, which if you don't have that set up for like Google Drive to share whatever service you use, like Nextcloud is what I use. If you're trying to sync between multiple PCs, or of course, if you need to back it up, it won't automatically be backed up. So just something I recommend personally. So as you can see, we have our board design. Now, obviously we have different options. So this is our actual dimensions here. And as you can see, holy crap, I believe, how many boards do we have? 5 for $2. That is wild. And I believe this is the, there may be some shipping costs as well. But look at that, 24 hours. Not all shops do that. Some of them take like a couple weeks because they may be like putting it all in one like big, board design, plating it up there. So say if I wanted like 10 of them, what's that go for? $5? All right. Maybe if you wanted a different color, that's where things kind of shoot up in price. So maybe if I want blue to match my printer, actually, that still ain't bad. I think some other things, obviously you'll increase your turnaround for different board colors and what have you. OSH Park is pretty similar. You can, I'm just going to paste in my Gerber location. Now these guys are based in the United States. I think their turnaround's a little longer, maybe like a few days or so, maybe up to like 5 or 6 working days. I'll have to double check here, but this is who I went with right now just because I didn't really want to risk it end up costing more to ship out the initial batch of boards I needed, which I only needed like a few of them for our printers just to test it out, make sure it works good to go. So obviously you can punch in your email address, and they're pretty, $12.85 is what I paid for my 3 boards that I got, and by default it's purple. If you want to up the amount of time it takes, they have like a black and like clear solder mask you can do as well, which looks pretty cool, but I just went ahead and went with purple because that'll match the printer pretty decently at least. Now JLPCB, they do have promos going like a lot of the times, so they can, as you can see, link it up, another $5.24 added up here. So that's for the same sort of production run. So it's a little bit cheaper, but the speed, as you can see, that's not DHL, so 15 to 20. If you bump up your order a bit, it's like more of a bulk order, they'll probably ship you DHL. Yeah, that right there, that's a pretty big turnaround time, and I'm only saving like $2. So I'd much rather just go local or somewhere in the US and have these guys fab out my boards. And I will say that JLC PCB, they make excellent quality boards. There are no issues with these guys. I highly recommend them, especially if you need like a big bulk order and you're okay with waiting a little bit. Yeah, if you need it quick, definitely recommend going local for like OSH Park, and there are a few others as well, but I just like these guys for smaller projects and just test runs for what have you like this. But that's going to be about it for now. I'm waiting on this particular board design to ship from OSH Park, so once I have it in, I'll show it off, and I'll probably have some more board design stuff in the future as I have some other projects I may need to do here in next few months or so. Hopefully I'll be recording more of these here, but I just want to thank you all for watching this video. I know it's a long one. Thanks for sticking with me. And if you have stuck this far, just want to thank you all for watching and have a great day. Subscribe, like the video, all that good stuff, and take her easy.